Hello, welcome back. So let me first open the chat. I changed the microphone from my phone to, I have a small microphone. It doesn't pick up voice as good. I mean, I have to speak louder, I guess, but the quality I think is a little bit better than phone microphone. I hope that this is good. Yeah, please let me know in the comments how it. So today we're gonna go on with raycasting and vision. Okay, cool. Now I made a small change. So there was a small bug yesterday before leaving, and the bug was related to this line. I defined this variable k outside of the first loop, and I never put it to mind int. Like I never put it to the minimum value. So the second loop wouldn't run more than once. And that would cause issues, like sometimes the platforms wouldn't be found, or like I mean it wouldn't check some of the grid cells and stuff, so because of that. And then yeah, that was the major problem. Now it's okay. We can I believe it is already built. And then we can try to run this. Okay, I have the chat now. Okay. And you can see that there are like it draws 4 lines, 4 rays to 4 corners of the rectangle, and it's consistent. It's okay. Yeah, you can see that it's cool. Maybe the only thing that needs to change is that this red box isn't the honest one, because like we want so let me show you in the code. Okay, here. So I also check for the edges of the scene. So like there is screen width and screen height. That's of course that should be taken into account when I'm drawing the red box. But since I'm only using it for debugging, I'm not going to. Yeah, I am not going to do that there. Maybe I should. Okay, I can try to just copy paste. I will just copy, and then here. Okay, how do we do this? We say, oh yeah, okay, there's a suggestion here. There is a left, and there is a left top. and then the size, the width, and the height. Okay. Bottom minus top. Very cool. Okay, now it should be consistent. There is one error. What is the error? Says that there is a P position. Oh yeah, okay. So P is the platform position. That doesn't exist here. How do I... So I can just remove this because there is no such thing as platforms. If for some reason my formatting doesn't work. Instead, I think I changed the settings and I messed up something. Sorry, there was error, no? Yeah. I missed, okay, what is the error? Okay, what is G? Basically G const G equal to, yeah. Zig build. We run this. Yeah, there is no error, and this thing is completely consistent. This square it's very good. Okay, this is cool. I quite like this. So now what I need to do, so here, for example, there are multiple rays being casted by the player. There's to this corner, top left corner, and then yeah, bottom left corner. But these things are hitting some wall here. So what I need is to find the where it hits this wall. Like, yeah, I need to find the what do we call these things? Like these points that are the I mean, what's the word for it? I had it in my mind. It's like I don't have it in my mind right now. Okay, but it's okay anyway. So these rays have to sort of be cut down, and then we can draw triangles between these new points that we find, and it sort of makes some kind of a vision. And then we need to add the corners of, like, we need to add also the FOV or the vision rectangle as well. And that should give us complete vision thing. So what I can do, I can actually add a platform. Oh no, it's not adding a platform. It's like I have to add these four corners to the vision thing. Okay. Do that. Yeah, here I need to add 4 more corners. I believe, oh, okay, I can just try to use the code that I used here. Because these are, okay. So I have left, right, top, bottom. Now the first thing that I need to do is to add these corners to my list. Try corners that append. Yeah, that's kind of correct, but yeah, so the X is left, right, right, left, and then these are bottom, bottom, top, top. I think there are more fields here. So how did I define corner here? Okay, there is position, there is PID. Okay, that's a difficult one. So I believe I have to put, because this one is not a platform. Maybe I should make the PIDs I32, and then that way I have negative values. I can put in -1 for the square of the field of view. And then, yeah, I can do that. I can also make it nullable. Like it is null for... Okay, let's try maybe nullable, I guess. The good thing with the nullable thing is that it just is like I am forced to treat it. Like I am forced to check every time what is this PID. Where do I use this PID? Okay, so here there is no such thing as X and Y. There is position, which is at t dot vec2 f, top and left. Okay, and then this thing is a PID, which is equal to null. And then they have angle and stuff that I have to calculate. Angle. This is equal to city math dot angle. No, at en tangente 2. And then this is top minus, yeah, exactly. This one is right and bottom. This is bottom left, top right. This is top left. Okay, that's cool. So we have angle, we have PID, we have position, or we have distance too that we have to calculate also. This 2, which is equal to t dot this 2 and then I need to send back to f. Okay, that should be okay for now. I now have 4 more corners. What is the most corners here? Okay, okay, it should be okay for now. Let's see if there's a compile error. There's one error. Oh yeah, so append needs allocator. Okay. So very cool. We now have all the corners considered. And it shrinks down even. Wow, this is cool. And that's okay. Very good. Okay, now what? Now we have to find where these corners hit first in their path, their collision points. And then we need to create a list, which is called the hit list, or hit, I guess. I'm gonna create this list here. It's city should be array list, I guess. Array list. And then so each of these things have a point and some angles. These are corners, I guess. I mean, I have to save them as corners, or it's a some point, and then there is it's a point, and then I will have to create another struct for hit point, but then it's exactly the same thing as the corner, because it has a position, it has angle, it has distance, and it has platform ID. That should be cool, I guess. What I can do is to... Okay, let's try this one first. Hits city.ArrayList, and then it's a corner array list. In the init, we have to destroy this thing. There's no allocator here. Oh yeah, okay. And then here we have to initialize it. Just that here, this is init capacity, and I have to pass how many we have. I'm gonna add, yeah, exactly the length. For some reason, my formatting doesn't work. I have to debug that. I have to fix that later, but it's okay now. So I have now hits. I need to use the hits for this thing. So how do we do that? We can create a function where we pass this corner, and then when these corners are passed to this function, we try to cast a ray to these corners, and then we find where the collision happens in between these two, and finally we update the hit list. To do that, so here I am just adding, I'm populating the corners here, so I'm not going to do it here. Just after drawing here, I'm going to call a function v.update hits. And I have to pass corners, by the way, so corners. Okay, so what does this thing do? It's just a function, update hits. Okay, there's a suggestion. I'm pretty sure it's bad, but okay, so this is okay. I have an array list of corners, that's good. Okay, and then you do, yeah, that's okay. Player, it's okay. Position, player position. Do I need those things? Okay, I'm gonna remove the rest for now. Yeah, you calculate the angle and stuff. I mean, corners have the angle and stuff calculated, so this is not what I mean. So what I need is to, okay, apparently I need the minimum and the maximum indices as well. Max int and min. So here I will also send min int, max int, because we have to loop through those. These are minimum indices and maximum indices for our grid cells. So I need to loop through all of them. And they are not usize. They are t.vec2f. t.vec2f. Cool. Now I define var I is equal to min int 0. Okay, and then while I is less than or equal to max int 0, I will add 1 to I, and then I will do var j equal to min int 1. Yes, exactly. Okay. So here we will have to go through our grid system, and then we have to check all of the platforms there. Exactly this. So I loop through all the grid cells that are visible to our player, and I check all the platforms, like all the PIDs that exist in this platforms. So first thing first, I need to see, okay, there is a vision step ID being set here. Okay, I don't need to check that anymore. It's for collision. What I need is another function which gives me the closest collision point between a platform and the ray that I'm casting. Okay, so to do that, okay, I will define const collision, which is equal to v dot get collision. I have to define this. I can use the raylib one. I mean, there is the raylib line collision thing. RL dot check collision. And there's a bunch of functions there, which I don't know why it doesn't show right now. But there is for collision for circle, rectangle, there should be line rectangle as well. Maybe I should try to use that for now. That's also an interesting proposition. Okay. Let's try the Raylib one first. Let's see what does it give us. rl.check collision. Okay, there should be rectangle line. No, I have to go check in there because it doesn't. There's something wrong with my auto-completion stuff if they don't work for some reason. That good. Raylib cheat sheet. Okay. I wish they had a dark theme. Okay, let's see it together. Okay, we are looking for check collision. Okay, here there's a circle line. I might be too small for you. Maybe get bigger. So there is a point circle, point triangle, point line, collision lines, which is, I mean, I hate this one. Collision lines. It has a really high precision for pixel calculation. The pixel part calculation has to have, I mean, precision should be around like 1, or I mean, we should be able to control the precision, but then when you don't do that, when you don't have that, crazy things happen, like points and lines that should hit each other, they don't hit, or it doesn't detect the collisions correctly many times. So apparently it doesn't have it. We need one that says line and rectangle. Yeah, we don't have it here. Okay, I have to write that function myself. So let's go back to code. We get to here. I need to write a function. That get collision PID, which is the platform. A collision between player and corners. So I have to look through all the corners. Corner position, or I can just send the corner itself basically. And then player position. Oh, we have access to player position. I don't have to send it. Or I might use it for enemies as well. Let's just send v.g.player.position. And the corner, I'm gonna send a reference from corner to this function. Hit the collision. That should be cool for now. We need another function here which says get collision. So vision. Okay, again, try to fill the whole thing. Not, yeah, I don't want this. There is PID, there is corner, and then there is position. And then the collision should be a nullable vector. So at the end of the function, we are going to return null. And here, okay, now I have to refresh my mind, find a way and understand how does the collision between a segment and a rectangle work. Because yeah, I haven't done this. To be written, to be implemented. Okay, you get the collisions. We get the collision point here if collision is not null. All. Okay, it should be added to the hit list, right? Try v.hit append, not that one. v.g.allocator, and then here I will need corner. Position is collision. PID is PID. No, PID is corner.pid. And then angle is corner.angle. This two is corner.this two. Okay. Now this will populate our hit list. And then finally, in draw vision, draw player vision here, we will have to draw the whole vision. Okay, that should work, I guess. Now, okay, how do we do this thing? How do we do get collision? So okay, so yeah, I'm gonna do a little bit of drawing for myself. Okay, we have some rectangle. And then Okay, and then there is a player. There is some points. Okay, I'm gonna do multiple. So there is a case that is like this, for example. Some other case where it's just the corner here. Some case like this. And I have to, okay, how do we do this though? Oh, okay, I see. This one is easier to remember. How do I, so I can remove these things. Okay, there are two collision points. So there is a segment here, and there is two other segments there. And then, I mean, there are four segments from each platform. We have to first find the one that is closest to the player somehow. How do we do that? I can see how to do that. I guess. Or I mean, okay, I can do. So the easiest way, let's do brute force. Okay, let's see the easiest way. The easiest way is to consider all of these walls of the platform and consider them as a segment. So these are four segments, and this is a segment. The array is a segment, and then we want to find the collision between these four segments. We find the collision, and then the closest point of these collisions for these two might be null, but for these two there are collisions, like there is a collision here, there's a collision here. So the closest point of this and yeah, the closest of these two will be the hit point that we want, and we will return that. So if oops, I wish I could. Okay, I guess I cannot. I can try to draw a new one. But anyway, we can see the point. The point is that if the line was like this, for example, I'm going to draw it in green. If it was like a green one, we don't care. We will have a four. No, like there will be no collision between this segment or with any of the segments in the rectangle platform, basically. So we don't care about those things. And oh, and then there is a special case where the corner itself is the closest point, and this is the most tricky one because Raylib doesn't detect this one as good, unfortunately. Otherwise you could just use the Raylib lines collision. For this we have to write the function. For this reason we have to write the collision of the lines segments ourselves. And since one of the segments is either horizontal or vertical, this could be simplified in some sense. How exactly, I don't know. I'm gonna try. Sorry. Okay. Yeah. Let's go back to the code. Okay. There is there was a way to do this maybe better if we could add all the walls that are necessary to check here. Since we are going through all the platforms here already, we can add these platform walls already into the area list walls. And then we would have to check through like we would check through all of these walls, and like here, if I'm trying to check the platform, instead of platform I would just do the walls. But then I don't know, I think that the logic would change because I'm using here platform ID. I'm putting the platform ID in each collision point and stuff, so I would have to define a wall ID and stuff. It would be more complicated in some sense, but yeah, I'm gonna try to keep it as simple for now. Let's see if this works. If it works, then maybe later I can make it a bit more complicated and more efficient. So I have a platform. It has 4 segments. I need to find which segments are the important ones. Oh, there is a case that the player is inside is inside a platform itself. I think we should skip those, because there will be no use for having vision inside the platform. Or maybe there will be. Okay, I'm gonna try to add nothing for now. Okay, so let's try to get the segments. There is a seg top, const seg top. So for segment, I guess I have to define a const segment. Struct start end. Even though it says start end, I mean I prefer only, yeah, I prefer to say position end. Or maybe just let's try to keep it as readable as possible. Start end should work. Now we do segment. So the start would be corner position, end would be corner position plus oops. Okay, it's just that I have to change this thing a little bit. These are not right. So the first value is it's not corner, by the way. This is okay. Const p is equal to v.g.platforms.items PID, and then here start is p.position, and is p.position plus p dot, I think it's size, right? Size 0, 0. So this is the left, sorry, this is, okay, it's for top. For top, this should be, yeah, that's it. That's it, okay. This one is for left. So left is, yeah, exactly that. And then right is, we increase X, and then X and Y, and the bottom is that exactly. Nice, okay. Now we have 4 segments for the platform. So obviously not all these segments are important for collision. Let's just try to keep it simple. I forget that every time. Go through them, find intersection, intersect some corner position, corner direction and stuff. Okay, yes, that's an interesting thing that it's suggesting, but I'm not going to do that. So okay, it's worth considering, but the segment doesn't have an intersect. Maybe I should write it for segment, or I'm going to keep it outside. Okay, here get segment collision, get collision seg segment to segment. And then the first one is segment, and then the second one is what's the second one? Is the start is player position v.g.player.position, and the end is corner.position. Okay, that should be okay. And then now, since this collision will be nullable, yes, exactly, I have to do this. Then I have to put them in some array list, I guess. Var cd.array list of c.vec to f, I guess, because I'm not passing the corner, so I'm expecting to have 1 point init capacity v.g.allocator, and there should be 4. Maximum 4 collision points will be returned, I guess. Is it maximum 4 or maximum 2? Like maximum 2, but yeah, okay. There cannot be more than 2. Defer calls.init, and then here I will say v.g.allocator. Cool. Now here, instead of returning, try calls.append that. Okay. Here there should be possibility for error. And then here there should be a try. Very cool. Segment to segment collision. We just try to append it. So this is a nullable thing. There is no error. Okay. Return null. Now we have to find which one of these two is okay. We don't know if there is anything in it. So here, find the closest collision points in holes and return it. Okay. Okay, to do that, I can just do if holes. Oh, okay, I can just do variable closest call equal to null. What is this? This is a, yeah, exactly. The nullable vector f. And then I will go for a loop calls.items. I will take call, and then okay, here I will return closest call. Okay, if closest call exists, closest do something. Yeah, I need thing. Okay, so if not, just put it equal to that. If the closest call exists, then we have to compare their distance if called okay, t dot dist2, have a function there, call, and v dot g dot player position. If this is less than closest one, then closest one should be this one. Okay, that's cool. And then we return the closest call. Okay. Okay, I need to write now the function get collision. Get collision segment to segment, and this shouldn't be there. Pub function. I have to move all of this into my data types basically later. But for now, I'm gonna write it here. Get collision segment to segment, and it gets two segments, and it has to return seg1 segment, and then seg2 segment. It has to return a nullable seg2s. So for now, return null at the end. Okay. How do we do this? So this is a part where I have to check different algorithms and codes that I have had in the past. So the thing is that if we want to do two segments generally to be checked, it's a little bit like you have to consider a more general formula for that. But then here we have a segment that is either vertical or horizontal, which is the platform segment. So that's why I am going to rename this thing to P segment. So for platform segment. And the second one should be, yeah, okay. I'm gonna put it in description. Turns the closest collision between a segment and a platform segment. Segment return value could be null if no collision is detected. Then what else? Okay, that should be cool. I can actually name this array, by the way. But anyway. So how do we do this? First, we need to find the direction of this ray. And then direction of this ray. Okay, I have to refresh my knowledge on this thing. I don't know how to do this. I will probably ask also AI for help. But since the AI cannot give me almost always, sometimes it gives me really not efficient codes, so I have to check this out, and then I have to also check because I had it on some other projects. I did this as well, so it will take a while. So it's a good point to end this stream right now, and I will be back in a few hours, probably 1 or 2 hours, no, 2 or 3 hours. Yeah, I will be back, and I will continue doing what is needed to be done. So first thing I need to do here is to update the GitHub code so you can follow if you want to check. Okay, doing the vision before segment to segment collision. Put the commit and push. So yeah, GitHub page is updated. You can check it out, and you will have yeah, you will see what is going on there. And thank you for watching. Don't forget to subscribe and like the video. That would help and support us a lot. See you again next time. Take care. And yeah, see you.